First thing I want to do is I want to eliminate this question. So continuing with trig equations, you look at B and C and D. Something's different. What's different? There's a squared. Okay? Squared means not only is it a trig equation, but it's quadratic. And how did we solve those quadratic equations last year? Most of the time by factoring. So what we need to do before we start the actual solving of the trig is we need to solve the quadratic portion. So I would suggest to make it a little bit, because you guys aren't used to seeing it like this. First of all, I should say we're solving in radians. Instead of tan theta, put an x. And then we'll replace that back with tan theta later. Because that might be easier to see, to factor. Well, this is one of those ax squared trinomials. Well, the first two terms must be 2x and x to multiply to 2x squared. The numbers here must be positive on 1 and negative 1. But the question is, does the positive go here or does the positive go here? Well, it all depends on what the middle term. So if I tried this, plus 1 minus 1, I know this works. I got to check to see if the middle works by rainbowing it. So I get minus 2x. I get plus x. Minus 2x plus x is negative x. So I factored it correctly. Okay. Do you remember what we did after we factored them? To solve? Remember what we did with each one? Think about it. Something times something is 0. Would you all agree that if this whole thing worked out to 0, this whole side would work out to 0? Because 0 times whatever this is still going to be 0, and that's an answer. So what value of x in the first set will make 2x plus 1 equal 0? Well, you just solve that. 2x equals negative 1. X equals negative 1/2. That's one of the answers. Here, what value of x makes this set of parentheses equal to 0? 1. You can really do that one in your head. Now, instead of x, put back tan theta. So I did the quadratic portion. Now I've got to take each one of these trig equations and solve them like we were doing last class. Okay. Remember, unit circle values mostly apply to sine and cosine. Like negative 1/2 is a unit circle value, right? But it doesn't apply with tan. It only applies with sine and cos. So I need to do this the long way. I need to do this, the quadrants, the reference angle, and then the actual angles. This one, however, is on the unit circle. So I can go straight to the answers. This is a unit circle value. This is not a unit circle value with tan. If you look at your unit circle, can you find a point where the y value divided by, because that's what tan is, the y divided x. Can you find a point where y divided x is 1 on your unit circle? Feel free to pull out your unit circle. Oh, nobody has a unit circle. Really? Oh, there you go. Thank you. You got one then? Well, if the y value divided the x value is 1, don't both of them have to be identical? So root 2 over 2 comma root 2 over 2, what angle is that at? In radians. Pi over 4. Is there another one where they're identical? At 5 pi over 4 because they're both negative. So I got those ones. Okay, so this I got to use my calculator. So what quadrants is tan negative? 2 and 4. That tells me where my answers are. Reference angle, take the inverse tan of the positive of the value that you're given. Always the positive. And remember, we're in radians, so your calculator should be in radians. If you haven't touched your calculator, it should probably still be in radians from the last class. Unless you decided to do some trig over the weekend or something. And you should get 0.464. So if the reference angle is 0.464 and the actual angle is in quadrant 2, how do I find the actual angle? Halfway around the circle in radians. Pi minus the reference angle. And in quadrant 4, how do I find the actual angle given the reference angle? All the way around the circle in radians, 2 pi minus the reference angle. And those will give me 2.678, 5.819. So there's all your answers. One we were able to use the unit circle, the other one we couldn't. Okay, C. First of all, make note degrees this time. It's got a squared in it, which means we're going to have to factor it. So let's, instead of write cos theta, let's just replace it with x for the time being, because that might be easier to factor looking like that. It's not a trinomial, which means what kind of factoring? DCF, what can I pull out? X, and I am left with 2x minus 1. Set each factor to 0. So this, well, x equals 0. That's one of the answers. I don't have to do any solving there. It's just, I know it's 0. This one, what value of x makes 2x minus 1 equals 0? Well, you got to add 1 and divide 2, so x equals 1/2. And then you can replace x back with cos theta. and then solve each one of those. Unit circle values. Cos theta equals 0. Can I use the unit circle? Yeah, I can. How about cos theta equals 1/2? Yep, I can use that too. It's always nice when we see those ones. Makes life a little bit quicker. So what values or at what angles is the x coordinate of the point 0? 90 degrees, yeah, because remember we're in degrees, and 270 degrees. Oh, sorry, that should be theta. That's... And this one? Good. And there they all are. Usually they like to give one of these on the provincial. And it's usually about a 4-mark question, which means it's one of the ones that's worth a lot of marks. Okay, next one, radians. And I've got tan, so chances are I'm going to be using my calculator. Unless tan theta equals 1 or 0 or -1, I'm going to be using my calculator. What do I need to do first? Sorry? Yeah. I need to pull the tan theta and the 6 over to this side. And when I do that, they become the opposite sign. So tan squared theta, I got to move the tan theta by subtracting tan theta from both sides. And when I move the 6 over by subtraction, I subtract 6. You don't have to replace it with x if you don't want to. You can factor it exactly like it looks. Like I said, I just find it a little bit easier to see without the tan thetas or the sine thetas or the cos thetas. This is a trinomial. Two numbers that add up to -1 multiply to -6. -3, +2. So now we need to solve by setting each one equal to 0. So what value of x makes x minus 3 equals 0? 3. What value of x makes x plus 2 equals 0? -2. And then I'll just replace x back with tan theta. What's that? No, if it's sine or cos, it would. Good question. And I think we'll see that a little bit later on. X plus 2 equals 0, x plus 2. So unit circle values, no. So for each one, I got to do the quadrants, calculator for the reference angle, calculator for the actual angles. Quadrants, calculator for the reference angle, calculator for the actual angles. So the first one, tan is positive in quadrants 1 and 3, which means, I mean, we could just sort of do them both at the same time. It means they must be negative in quadrants 2 and 4 over here. The reference angle, take the inverse tan of the positive. Well, on this side, it's already positive. On this side, you've got to change the -2 to +2. Remember 3 decimal places. That should get you 1.249 in that side. And it should give you 1.107 on this side. So now we're ready to find the actual angles. Oops. So in quadrant 1, what's theta? If the reference angle is 1.249, same in quadrant 1. So that's one of my answers. What about quadrant 3? How do I find theta? Not 180 because we're in radians. Pi plus 1.249. Yeah. And that will get you 4.391. So that's the 2 solutions for that side. For this side, how do I find the measure in quadrant 2? Halfway around minus. Halfway around is pi minus the reference angle. Remember this time the reference angle is 1.107. So that's going to give you an answer of 2.035. And finally, in quadrant 4, sorry, I'm running out of space here. Theta is going to be 2 pi all the way around the circle minus the reference angle, 1.107. And 2 pi minus 1.107 on your calculator will give you 5.176. So that's a pretty complex one. So we have to pull the 2 over to get sine squared theta minus sine theta minus 2 is equal to 0. Just a note, we're in radians. Again, you can factor it as it is, or you can replace the sine theta with x and factor from there. And when you do, you should get x minus 2 times x plus 1 equals 0. Set each factor equal to 0 and solve for x to get your solution. So x is 2 from this factor. X works out to -1 from this one. And then replace x back with sine theta. Yeah. Absolutely. Yeah. If it's sine, or we talked about this the other day, if it's sine or cosine, and if it's not between -1 and +1, you'll always get an error. So, I mean, like what you can do is just pretend like you're using your calculator. So quadrants 1 and 2, take the sine inverse of 2, but then you get error, which means you can't do it. There is no such angle that exists. So on this side, there will be no solution. It might be easier just to go right through with it and use your calculator rather than trying to remember that little tidbit. Okay? Because it doesn't take it long for you to discover that something's wrong. This next one, though, we've got a UCV. And remember, we're in radians. 3 pi over 2. So in this one, only one answer out of all of this. 3 pi over 2. Because the other side didn't work. And this side only gives us one solution. Okay. Okay. Last one here with the quadratics. Well, pull the 6 over. So I get sec squared theta minus sec theta minus 6 equals 0. If you want, replace sec theta with x. It's a trinomial where we're looking for a sum of -1 and a product of -6. Two numbers that multiply to -6 must be 3 and 2 must be in there somewhere. Which one? Which one's negative? Which one's positive? But that'll give you +1 if you add them. Right, so -3 plus 2. Good. Solve each side, or solve each factor, sorry, make it equal to 0. So in this one, what value of x makes x minus 3 equal to 0? 3. This one, what value of x makes x plus 2 equal to 0? -2. And then replace that with sec theta. Remember what we did when we got one of these ones, these trig ratios? Yeah. Flip it to the one we know, which means flip the other side too. So this flips to cos theta, reciprocal, which means this flips to 1/3. This flips to cos theta, which means this flips to -1/2. And that's a UCV value. But the first one is not. So let's do the UCV one first, get that one out of the way. I am looking for angles where the x coordinate is -1/2 in radians. 2 pi over 3 and 4 pi over 3, that is correct. And with this one, I got to go the long way, quadrants, reference angle, and then final answers. What quadrants are my answers going to be in? cos positive, 1 and 4. Reference angle, take the inverse cos of 1/3. And make sure your calculator's in the right mode. And that should give you 1.231. And so my answers. Again, they're in quadrant 1 and quadrant 4. Well, what's the answer in quadrant 1? The same as the reference angle. So there's another solution. Quadrant 4, I have to get it by doing the whole circle 2 pi minus the reference angle. And that gives me 5.052, I believe. Okay. So you can see the quadratic is just, it's that extra step of factoring and solving each factor, making it equal to 0. That's the extra step. Otherwise, once you get to the trig, it was just like we've done since the beginning of this lesson. Okay. No, let's stop there for today, because that's quite a bit.